sketch it a little bit different so that you can easily see the orientation. Here's A, and here's B, and here's a theta. All right. So like we did for the triangle thing, we're going to embed this one into what is it? XY coordinate system. So here's the first part from here, arrow. This is your solution, all right? You have to sketch this XY plane and label it correctly. How do you label this one? A here, I put little c. I just put the little c. That all involves the law of cosine, right? B here and the c there, right? I'm going to take that plate and rotate it around and put that c over here and b over there. And draw a circle first and sketch a triangle like that. Okay, and then that's A. Can you imagine that? Take that triangle and rotate a little bit around and put that C at the origin and B on the positive x-axis, like that. Because we're just rotating it, the angle theta doesn't change. Theta is still there, right? All right. Let's identify this coordinate, xy coordinate of B now, using the information that's given. So suppose we have this number A and B and C and theta is given, and we try to figure out how they're related, namely the law of cosine, right? So using this A, B, C, theta, how would you write this coordinate of B? Well, one coordinate is easy, right? Y coordinate, it's on the x-axis, right? What is the x coordinate? It's not a number, it's some information that you're using here. A, right? It's little a, because the length of this one is A, so from 0 to there is A, right? So what else we know is a B, right? So B is not really the part of this coordinate here and A exit for the point A. B is just this length here, right? Correct? And C is this length. Neither of this is perfectly perpendicular or horizontal. So it's not that simple. So we're just going to write x and y. We don't know. So we call it x and y. All right. Anyway, that point x and y is on the circle anyway. And we're looking at a circle with radius, some angle theta. We know how to connect it with the theta in x and y, right? So let's write that down. How about sine theta? What is sine theta here? Theta is this angle, and that's the terminal point, which is really the triangle vertex. So that y coordinate there divided by something we know. Not r. Better. What is the radius of the circle? A is a little short here, right? B is the long one, right? So that's the B down here. Is that right? Okay. B is a given information that we want to use. Y is not. Y is something that we have to create, but we wanted to know. What about cosine theta? X coordinate of that point and divided by B. Isn't that right? So if you draw a circle with, this falls out. This is something we've been considering all the time. I draw the circle, so what else do we write it down right next to circle? X squared plus y squared equals b squared. R squared here is a b, right? So if you draw a circle like this, these are the things that you automatically just write it down all the time before you do anything. All right. Now, this is the answer to the guy. He's almost now one block. So we've got to prepare our answer. Is that these 2 points in here, A and B, the distance between these 2 points is given in our information, right? Which is C. But if you have 2 coordinates like this, there's a way to compute distance between these 2 points, right? Using some sort of formula. It's called distance formula, right? So here's the idea that leads us to the law of cosine. The opposite side of that angle is what? It's known to be c. It's given. But there's a different way to calculate this opposite side. So opposite side is also distance between which and which point? The point over there called A and point down there B. Isn't that right? That's the same segment. It's given, but we have new information, x, y, and a0. From there, we can calculate the distance between these 2 points. So it's a two different way of looking at it. If you connect those things, law of cosine falls out. That's the one-liner. So he's now here and grabbed you and asked, why is the law of cosine true? Because there's you can use a distance formula to calculate the opposite side of the angle, and that connection becomes the law of cosine. All right? Opposite side can be calculated using distance formula in coordinate geometry. Long liner. All right, so here's the thing. Now here's the beginning of the calculation. C is the opposite side. That's this one. But what about distance formula? Who remembers distance formula? It has this long square root, and there's this something like this, squared. All right? That's right. x2, y2 minus y1, exactly, yeah. This came from Pythagorean theorem, and that's exactly right. So here it's a difference of x-coordinate, here's difference of y-coordinate. So what is the two x-coordinates of these points A and B here? X is x-coordinate, right? What about here? A is the x-coordinate, right? And you subtract those two. So that's going to be the distance between the two x-coordinate. How about y-coordinate? Y is one of these points there. The other one has 0, right? So it's minus 0. So this is the most important statement of the whole thing. The idea of looking at opposite side as a distance formula. All right, from here it's just an algebra working out. It's not too bad. So how do you get rid of this square root? What do we do to both sides? You square it, so it becomes c squared, and as we square the right hand side, the square root disappears, so it just becomes like this. Y minus 0 is just y, right? Correct? So you can write it simply like this, y squared. Now this statement involves c. C is alright, it is given context, but x and y is not, right? So try to rewrite this x and y in terms of what is given, a, b, and c, and theta is our goal. So first thing we're going to do is work on this x minus a squared. We can expand this one, we can FOIL this one. Answer is not x squared minus a squared, right? So what is that? There is x squared involved, and there is a positive a squared involved, but there is something more in between, according to binomial theorem. Minus 2 a x is correct, right? So this is a side note. You don't have to do this in your proof. X minus a multiplied by x minus a is the meaning of x minus a squared. And when you multiply, you have to multiply each of the term from the top row to the bottom row. So you can see x squared. You can see as you combine these cross terms, negative ax and negative ax, in whatever order, and here's a plus a squared as you multiply these two terms. That's what this one is. So x minus a squared is going to be replaced like this. So here, c squared is equal to now x squared minus 2ax plus a squared plus y squared. Okay? You don't have to touch a and b and c and theta. Just think about how to remove x squared and y squared and x in those. Let me just first group this x squared and y squared. Alright, we need to get rid of that x squared and y squared. The squared terms, if I group it like this, who has an idea just to what to do about that x squared plus y squared? All the information is actually summarized around this circle in here, right? So let me scroll back it up here. We try to do something about x squared plus y squared. What do you see in here about x squared plus y squared? Equals b squared, right? Circle equation. X squared plus y squared is going to be b squared, no matter what the x and y is, as long as it's on the circle. So what is the next line? C squared equals, this whole thing is now b squared, right? That's written right here. So let me use green line. That kicks in right there. Make sense? So minus 2ax plus a squared. The only thing that you have to get rid of now is x, right? If x is replaced by a, b, c, and theta, and we're done. So let's go back and see who wants to do something about x in here. Where is the information? Can we replace x by looking at this information here in terms of what's given, a, b, c, and theta? Any idea? How about this guy? You see something about this? X is cosine theta times b, correct? Yeah. So that's theta is given, b is given, things like that. So we're going to notice it here. Looky here. X cosine theta is x over b, right? That was the definition of cosine. But what is x here then? B times the cosine theta. I can replace that x with this one. So I'm going to do that. C squared is b squared minus 2a. X is now replaced by this identity here. B times cosine theta. Plus a squared. Now we got rid of all the x and y. This statement is just about a, b, and c, and theta, right? Do you remember this statement? C squared is a squared plus b squared minus 2ab times cosine theta. This is law of cosine. So the guy asks you again why law of cosine is true, and then you got to answer it one line, or what is it? The opposite side computed by distance formula foils to law of cosine, right? Something like that. Yes. What's that? It's 3 points. So if you get 77, it changes to this one here? Yes, that'd be great. So all that, like I said, after you've practiced it one time, it's not too bad. You can do it. And with this idea, this is something we've been practicing a long time, right? Think about it. Boom, you do that automatically within 3 minutes. And then you write down this key idea, opposite side C, distance formula. And then from here is a little bit of a practice in algebra, and that another 3 minutes. So altogether 7 minutes is given. So you got to definitely practice a little bit. But once you practice, not too bad. All right, the reason that